This is the halfway point of the scientific method and perhaps the most known step. This is when you test the hypothesis you come up with. So if the hypothesis is the possible answer for the research question, which is where you started with, the testing part is where you see if that possible answer is the best answer you currently have. Of course, in science, you'll never get a definitive answer because we always have an open mind to change that in case there's better evidence or better methods to try it out. But the point is, we gotta test out that hypothesis, and that takes us to the next step of the scientific method. Now, this video will focus mostly on what I call the correlational method of research. And this, you do this sometimes when you cannot really perform true experiments. But know that in science, we're going to try as hard as we can to do true experiments because the experiments can imply causation. And we'll talk more about that in a second. But sometimes it's impossible to perform experiments. It may be against the law to do it. For example, let's say that you have cancer and cigarettes. Does cigarette smoking cause cancer or not? Well, the question is valid, and a lot of people would tend to say yes, but until you can actually separate the people in two groups and have one people smoke and one people not smoke, and you randomly assort them to these groups, there's nothing special about the groups. The only difference between them is that one group smokes and the other one group doesn't, and you were the one that made that happen. You controlled that. Then you can say if the group that smoked had more cancer than the other group, that cigarette smoke was probably what caused it. But it would be kind of illegal to do that because you're forcing harm on someone else, so it's against the law. Sometimes also the cost is too much. You know, there are a lot of applications, especially in physics, things that we wanted to do, but they're too costly, and so we can't do it. So we have to do something else instead. Sometimes it's not a practical thing. You can't replicate exactly what happens inside the sun. So if you want to learn about what happens in the sun, sometimes all you can do is observe the sun and see relationships between events that occur inside the sun. Sometimes all you can do is a model, a small-scale model that represents the sun, but it's not really the sun, so it's just, you know, kind of like a representative of it. And sometimes when you're actually trying to perform the experiment, you end up changing what you're studying. For example, let's say that you're trying to study monkey behavior. If you're trying to study the monkey behavior, the act of you studying the monkeys will definitely change the way the monkeys are behaving because they feel observed. They feel that they're not in the natural conditions. You know, even if you try to stay hidden, it will never be perfect. And if you do play with them and actually see how they would do and how they react, if you do an experiment with them, then it's not really a natural event, is it? Because it's something that you're creating. So all of these are examples of situations where you can't really perform an experiment. So in examples like that, the best thing you can do is methodically collect information to establish a connection between events. Oh, there was a solar flare and then there's a geomagnetic storm. The monkey does this when he wants attention or when he wants to become the alpha, the most important of the group. Oh, smoking does tend to cause cancer, or it seems to be related to cancer because it's more common among the people who do smoke cigarettes than people who do not, and certain kinds of cancer at least. So by recording these relationships, though, I am not actually truly controlling anything. And what that means is that all I can do is establish a correlation or a measurement of how closely related those two things are. For example, smoking and cancer. But I can never say from the correlational data that A causes B. I can only say that A is related or connected to B. And examples of things like this are observational studies, like the one we talked about in the monkeys, archival research, where you just go back to data that's already been collected and you look at the patterns that show up on that data, or surveys that you do and things like that, and some sorts of model experiments. You can even do true experiments which are in models, but you can never really say this is exactly what happens in real life because, again, it's just a model. And we'll talk more about models later in the video lecture series, but this is what you need to know about correlational studies.